Hey folks, 12.1, sequences. This stuff's not bad. Here's number 2, a to the n equals 5n minus 1. So they want us to get the first 5 terms, so we need to figure out a1, a2, a3, a4, and a5. So that means you just plug in 1 for n. So 5 times 1 minus 1, 4. Now a2, plug in 2. 5 times 2 is 10 minus 1 is 9. A3, plug in 3, right, for n. So 5 times 3 is 15, minus 1 is 14. A4, plug in 4 for n. 5 times 4 is 20, minus 1 is 19. A5, 5 times 5 is 25, minus 1 is 24. So the sequence, 4, 9, 14, 19, 24, it goes on forever and ever and ever. So basically, how far is it from here to here? 5, 5, 5, 5. Okay, so that's all. It's just imagine if someone said, hey, come up, here's a list of numbers, write a little like computer program to explain it. That's all. So here's number 10. A to the n equals 3 to the n over n cubed. A1, A2, A3, A4, A5. So that's going to be 3 to the 1 over 3 cubed, which is 3 over 27. Okay, you can probably reduce that. Pen's dying. A to the 2, that's going to be 3 squared over 2 cubed. Just plugging in 2 for n. So that's going to be 9 over 8. It's got messy. A3 is going to be 3 to the 3 over 3 to the 3. Oh, that's just going to be 1. This is a weird pattern. A4, 3 to the 4 over 4 cubed. 81 over 4 times 4 times 4. 64. A to the 5, 3 to the 5 over 5 cubed. 5 cubed is 125. 3 to the 5th, 3 times 81, 243. So that's just a weird pattern. That one was weird. 14 is interesting because there's this little negative 1 to the n. Negative 1 to the n or negative 1 to the n plus 1, that makes things alternate. So remember, negative 1 to an even power, negative 1 to an even power is going to be 1. Negative 1 to an odd power is going to be negative. So let us try number 14. A to the n is equal to negative 1 to the n, 3 to the n. So a to the 1, they just want the first 5 again. So a to the 1, that's negative 1 to the 1 times 3 to the 1. So negative 1 to an odd is negative, so that's just going to be negative 3. A2, negative 1 squared times 3 squared. So that's going to be positive 9. A3, negative 1 to the 3 times 3 cubed. So this is negative because it's odd, times 3 cubed, 27. What the? Negative. This is negative. What did I just say? So negative 1 cubed is odd, so it's negative times, that's 27. See how it's alternating? Negative, positive, negative. So then the next one's going to have to be positive, and the next one's going to have to be negative. And if you do the work, you can confirm that. Okay. Let's see. Find the general term for the sequence whose first 5 terms are shown. Find a general term. Oh, that's tough. So, what did I say to do that one? What did I say to do? Oh, 1 through 12, 1 through 63 EOO. I did say to do that. Okay. Find a general one. So let's try this out. Can I do this in my head? We shall find out. Okay, so 20. It goes 7, 14, 21, 28, 30. 35. So we definitely see the pattern. So we need to come up with the pattern for a sub n. So we're going to add 7, add 7, add 7, add 7. But it starts at 7. So maybe the first thing would be 7n, 7, 1, oh, 7n? That seems good. Again, just takes practice, so if it's 1, I get 7n. If n is 2, n is 3, n is 4. Okay, that worked. That's tricky. I had to think it through. Okay, let's try something a little trickier. Again, I didn't prepare for this lecture, so let's see what happens. Negative 3, negative 2, negative 1, 0, 1, dot, dot, dot. So it starts at negative 3, but it's increasing by 1. So let's see if it's increasing by 1. We're adding n. So a sub n is going to be, well, the first guy is negative 3. There's got to be a formula in here. Oh, I'm sure there's a formula. So the difference, so I think we're interested in the first number in the sequence, and the difference. So the first number in the sequence is negative 3, and then how do you get to the next number? You add 1. So now I'm scrolling up because I feel like there was a formula that I should have written down to begin with. And as I just ramble and talk, okay, okay. Did they give me one? No. Okay. Oh, it's alternating? They didn't really give me a pattern? What the? Okay, I'm going to try pausing for 1 second. Let's pause. Okay, so this is a little bit tricky. So 8n. So I'm going to need a number, and then I'm going to sort of add 1. add 1, add 1, add 1, add 1. So what's the first number that I would actually use? Negative 4, because when I add 1, I get there to the beginning. And then if I add 1 again, I get there, and there, and there. Whew. Okay, that was tricky. The book might write this as n minus 4. Negative 4 plus n makes more sense to me. Let's try another one, since that didn't go so well. That was number 22. Oh gosh, oh gosh. Okay, let's see if I have... I'm looking at number 24, and I don't know what to do, but maybe I can figure it out. 1 over e squared plus 1 over, not plus, just comma, 1 over e, 1, e squared. Now, e squared on bottom, isn't that just e to the negative 2, e to the minus 1, 1 over e is that? Anything, like where did the e go? It's just e to the 0, e to the 1, e to the 2. So I sort of rewrote the pattern like this, and now if I use similar logic as I did before, so I need to add 1, add 1, add 1. So it's going to be e to the negative 3 plus n. So, because I need to, the first one, when I put 1 in, negative 3 plus 1 is negative 2. And then if I add 1 again, I get there. If I add 1, I get there. So the book might actually call this e to the n minus 3, because they just switch it to make it look prettier. Okay, so that's pretty tough. But anyhow, when you try and figure these out, look at the back of the book and you'll see that it works, and then try the first couple, n equal 1, 2, 3, and be like, oh, okay, I get it. But yes, I agree. Pretty tricky. We're in what, 12.1. And, let me introduce an idea called the factorial. So on your calculator, have I talked this before? Let's see, 4 factorial is 4 times 3 times 2 times 1, which happens to be 24. 5 factorial is 5 times 4 times 3 times 2 times 1, which happens to be 120. So that little exclamation point is called the factorial. Sometimes they call it bang, so maybe 4 bang. And you should have a button on your calculator that looks like that. So you just hit 4, exclamation point, enter, and it should spit out 24. I think if you just type in Google 4, exclamation point, enter, it'll also spit out 24. So 38, they want the first 5 terms, so a to the n is 5 over n factorial. Okay, so that's going to be, so a to the 1 is 5 over 1 factorial, which is 5 over 1, which is 5. A2 is 5 over 2 factorial, which is 5 over 2 times 1, which is 2. A3 is 5 over 3 factorial, which is 5 over 3 times 2 times 1, which is 6. And then A4 is 5 over 4 factorial, which we said is 24, so 5 over 24. And A5 is 5 over 5 factorial, and we said 5 factorial is that, so that's going to be 5 over 120, and those are the first 5 terms of that. On a side note, if anyone were to ever ask, 0 factorial by definition is 1. Why? Complicated, just believe it. Okay, become a math major. Let's see, then what do we go to? Oh, we're still working on these, okay. Let's try 50. Oh, the Greek letter sigma, summation. 50. That's the capital letter sigma in the Greek alphabet. Sigma S, summation. So the sum of I equal 1 to 5 of I cubed. So it's like a little computer program. So it says, let's let I be 1. So that's 1 cubed, summation, plus. And then sort of like a counter, it goes from I equal 1 to 5. So 1, 2, 3, 4, 5. So then 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. And then you just throw that all into your calculator. See how it started at 1, it ended at 5? Throw it into your calculator, get an answer. Okay, 52. I got a little lazy. You can figure out the answer there. 52, summation of I equal 1 to 6 of 3i minus 2. So plug in 1. 3 minus 2 is 1. Plug in 2. Multiply 6 minus 2 is 4. Plug in 3. 9 minus 2 is 7. Plug in 4. 3 times 4 is 12. 12 minus 2 is 10. 1, 2, 3, 4. Plug in 5. 15 minus 2 is 13. Plug in the last one, 6. 18 minus 2 is 16. And then you add them all up. Let's see if I can add these up. That's going to be, those make 20. So that's 20, 30, 40, 51. Okay. And what did I say to go to? 63. Oh my gosh, there's more. In the following exercise, write each sum using summation notation. Oh, okay. That'll be fun. So I'll do 62. 62, 1/4 plus 1/16 plus 1 over 64 plus 1 over 256. So I recognize that as 4, 4 squared, 4 cubed, 4 to the 4th. So it's the summation from I equal 1 to 4, because there's 4 things, of 4 to the I. Don't confuse this I with the imaginary number I. It's just a letter, like a counter. Could be K, could be N. It's usually N, sometimes K. They went with I just to be interesting. Okay, that is 12.1.